previous years of math, you learned how to solve for missing angles of right angle triangles, okay? But what about triangles that are not right angled? Okay, in order to solve triangles that are not right angled, oblique is any triangle that doesn't have a 90-degree angle. We need some new tools. The first tool is the sine law. This is going to be the most popular out of the two laws. I'm going to show you how to do that. What did you use in trigonometry in grade 11? You used, probably your teachers used something catchy like SOHCAHTOA. Do you remember that? We're not using that anymore. Throw it out. Just go. Right? Like that's out. You can still use it if it's a 90-degree angle. But let me tell you this, the province is going to make sure that it's not a right triangle. I can guarantee you that you're not going to be able to use SOHCAHTOA. So I just don't even go there. I don't even go there because sine law and cosine law replaces all of that. So here we go. You ready? I'm going to use 3 different colors here. Just so you know, if you want to do what I'm doing here. This is what the sine law says. That sine of angle D divided by the side across from it, right? This is angle D. This is the side across from it. If you did that, and you did that the same with angle E and side E, you did the same with angle F and side F, they would all be equal to each other. That's what the sine law states. So it's very important that you recognize that there are 3 pairs. This is the first pair. Okay, then the E, this one here, is paired up with E right there. Oops. And F, angle F, side F, is the third pair. And so this is the sine law in a nutshell. This is it. Okay. I will write down sine law. Okay. And I will already tell you next to it, you need a pair. Right now, this might not make sense to you, but later on when you review and you add it to your study sheet, yeah, go ahead. So it works with the following scenarios. You know what? I'm going to skip the scenarios for now. This is what I want you to highlight down here. Remember, if you have a side angle pair, we use the sine law. That's what I want you to remember. Okay? So let's go to 5. Let's use this. Okay. So we're going to start with using the sine law to calculate side length. It says, calculate the length of side A. Yeah, go ahead. You notice that there's 2 angles given, right? But you also notice that this angle is across that side. I'm just going to pause for a bit. Angle here. You have a pair, right? Very important. If you have a pair, what are you thinking? Which law? The only law you know right now. Sine law. No question about it, guys. I'm guaranteeing you that it's sine law if you have a pair. Okay? So watch how this works. It's actually very, very easy if you know what you're doing. You're going to pair this up. You're going to say sine of 52 degrees divided by the side length across from that angle, 16.8 centimeters. Then you're going to find out what else can I do at the moment. As is, what information do I have? What additional information do I have? I have that angle, correct? Which is across this side. So that angle I can use to solve for that side length. Watch this. You're going to go sine of 72 degrees over side A, like that. This is also a pair, but you don't know one of the pieces. I'm going to pause here for a second. How many values does the question need to give you in order for you to be able to solve? We have 1, 2, 3. You need 3 pieces. Now you can solve it. Okay? So to solve for A, you're going to cross multiply and divide because all of these are numbers. You cross multiply and you divide. This is not work though. This is just for you to figure out what needs to be done. 16.8 times sine of 72 degrees divided by sine of 52 degrees. Okay, just leave it on my desk. And let's solve this. Grab your calculator. I'm going to go 16.8 times sine of 72 degrees divided by sine of 52 degrees. Please do this as well with your calculators to make sure this works out for you. We're solving for a side length, correct? So this is going to be in centimeters. You should get 20.28 centimeters. 20.28. Question. Can I somehow solve for side C as is? The answer is no, not as is, because I don't know this angle. If I had this angle, I could find side C. Okay? Is there a way to find angle C right now? Yes? That's correct. You've got 2 out of the 3 angles. So to find angle C, I'm just going to do this. Angle C is 180 minus 52 minus 72. That's correct. That's 56 degrees. I can now solve for side C, correct? How would I start? What I would suggest, and that's just me, I would keep the pair that I started with earlier. I would keep that one. Even though you now have a new pair, correct? You do know the side A. So technically you could pair this up. But what if you made a mistake here? It's going to carry over. So I will stick with the pair that I was provided with. And now I'm going to go sine of C. Let's do this first just to help us out. Sine of C over C. Copy this again. Please don't try to save a few seconds, okay? And ignore or make a notation error. So this 56 goes in there, which appeared over here. I don't want to call anybody lazy because that's not what, usually it's not that you're lazy, it's just like you want to be efficient. I get it, right? You want to try to save your time and energy for something else. But I wouldn't consider you lazy. You're just trying to see like what is the bare minimum that I need to do. Why not? Okay? Let's solve for C here. Follow me. 16.8 times sine of 56 divided by sine of 52. That is 17.67, right? right? You're waiting for that. $17.67. And if you're watching this at home, I'm doing this, right? I'm going up and down with my hands as you're, just to make your day. Oh, so by the way, I did this work right beside, okay? So I meant to, technically it should have gone under this line here, but it doesn't matter. We got both answers side by side. Before I let you do some work, okay? Does sine law work with right triangles, you think? Does it work with non-right triangles? It works with any triangle. A triangle has how many sides? 3 sides. If it's got 3 sides and you have a pair, sine law is the go-to. It's your go-to, okay? It's your goat. All right? Anyways, no SOHCAHTOA, please. Don't do SOHCAHTOA. Don't do SOHCAHTOA. Because I haven't seen a single 90-degree angle on the exam, ever. So they want to know, did you learn sine law and cosine law, okay? So I'm going to stop here. I'm going to ask you to try, go to page 6. Question? Yeah. I am I think so. Whoa. Yes, I am. Yeah. Go to page 6. And I want you to try those right there. And I'm going to give you the answers to the first couple. I want you to solve, listen carefully, I want you to solve for side Z and side X. So put a question mark. I basically want you to solve for everything that's missing. So side Z, you should get 624.91. Side X, you should get 1315.01. I will also give you the answers to the next question. Side M, you're going to get 12.40. And side L is going to be 17.64. Let me see if I can actually fit all of them on there. Let me see. I think I can make this work, yeah. So for C, side P is 54.29 and side R is 31.58. So I want you to show me work and solve for those sides. At the very beginning, you have to be you have to know what you're doing, okay? You can't just solve for any side you want at first. You've got your pair, start with your pair. What about the first one? Angle Z will allow you to solve for side Z, right? You're going to do that first. Do your sine law. Then you're going to solve for side X. But you need angle X4, right? How would you find angle X on that one? Sum of triangle. Sum of triangle. They all should always add up to 180. Anyways, practice this before we do angles, okay?